Let's get this crazy block of text formatted so that it actually looks presentable for our user. And the really good news is we aren't going to have to do any of this manually. Because we ask the AI to return the recipe formatted in a markdown format, we can use a package called React Markdown. I think there's a number of other ones, but this is a very popular one, to turn the markdown formatted text into something that renders as HTML. You can click on the screenshot here to go to the npm package for React Markdown. I believe it will automatically bump you down to the section that shows you how to use it. And since you will often find yourself using third-party packages to help you out in your React codebase, we are going to turn this into a challenge. First, let me come over to the Claude recipe here and I'll type out the challenge text. You know, reading documentation is one of the most common things you'll find yourself doing as a software engineer, and oftentimes other people have written code that does the task that you are trying to do. So it's really common to find a third-party package like we have here with React Markdown that can just accomplish our task and allow us to complete features a lot faster. So I think this will be a good exercise, even though it's more React adjacent using a third-party package. So your challenge is to see if you can figure out how to use the React Markdown package. I've included it here in the list of dependencies, but if you're following along on your own machine, you will need to make sure that you npm install react-markdown. All of that information is going to be here on the npm page anyway. But I want you to use React Markdown so that you can render props.recipe, which currently is this big block of text, into something that's at least a little bit more presentable. And actually, you know what? Something I've already taken care of that I completely forgot I had taken care of was over in our index.css. I added a couple of rules that will help format the resulting markdown that gets turned into React elements a little bit nicer. This means all you'll have to do is add this suggested recipe container class to the section right here. I guess I should probably type that in too. Okay, that should be pretty straightforward. All right, it's your time to shine. Go check out the documentation for React Markdown by clicking this screenshot and give this challenge your best shot. All right, over in the documentation, we can see that what we need to do is import React Markdown from React-Markdown. And this thing that we're importing is a component. Unlike all of the custom components that we have been using so far, like our ingredients list component is a self-closing component, our Claude recipe component is self-closing as well. If you look in the documentation, you can see that this React Markdown component has an opening and a closing tag. And so we will go ahead and render React Markdown. And on the other end of props.recipe, which we're passing in, we will render the other half of React Markdown. And this is small enough, I don't think we need this to be on its own line. We'll just do that. This concept of having separate opening and closing tags for your custom components, it's something that you'll see pretty regularly in React. It's using a concept called children, but for the most part, I'm not going to be covering React children in this course. Instead, that is something that I cover in my advanced React course. Okay, let's hit save. You can see I put back in my default ingredients from the last scrim that we created, and I'll click get a recipe. Once that recipe comes in, let's scroll down, and wow, look at that. That is looking so much better than it did before. Let's go ahead and add our class name here just to see how that changes things. This was, I'm not going to guess it. Let's go over here, suggested recipe container. And let's try again. We'll hit save, click get a recipe, and we can scroll down, and awesome. Okay, this looks a lot more like the design that we saw in Figma. The last thing that I want to add here is a transition that's a little bit nicer than just jumping straight into this text. So I think I'm going to add an H2 here that just says something like Chef Claude recommends. And then we need to keep in mind that for those using assistive technologies, if we're conditionally rendering this section, we need to add an aria live equals polite. This way, when React conditionally renders it to the page for the first time, it will be announced and read through the assistive technologies. Let's go ahead and hit save, and we'll just see what our new H2 looks like. Okay, Chef Claude recommends. Awesome. And that, folks, represents a perfect stopping point for us in our Chef Claude app. Now, it's not perfect by any means. We actually are going to be revisiting this again in the next section, but we have a few more things that we need to learn about first. And you are probably getting pretty tired of spaghetti bolognese and creamy chicken and pasta bake. It's a lot of carbs to be taken in. We have learned so much in this section. The things that we've learned in this section represent some of the most commonly used things in React. And so before we move on, I'd like to do a quick recap to take a look back at everything we've learned before we're ready to move on and continue learning some awesome things about React and continue working on some amazing projects. Holy cow, we have made it to the end of section 3. This was a meaty section, and you have finally built your first interactive React app. Congratulations. With the knowledge that you gained and practiced in this section, the sky is the limit as to what you can build. Let's do a quick recap of the things that we've learned. In the process of building our Chef Claude app, we learned about event listeners, which are the basis of interactivity on the web. From there, we spent a long time learning about state in React. State gives us a chance to maintain data between re-renders of React and cause new re-renders in React so that we can follow the paradigm of React, which says that the UI, or what the user sees, should be a function of the state. This gives us a super declarative API in React, which allows us to simply update the data that React is maintaining and rely on React to update the view accordingly. We discovered a number of different ways that we can conditionally render parts of our app based on the state or the incoming props for any given component. This gives us not only flexibility in what actually gets displayed to the browser, but also gives us a chance to add another interactive element to our app. We learned all about forms in React, which gives us a chance to collect information from the user and do something with it. We could send it off to a database to be stored, which of course is a very important component when it comes to interactive and dynamic web applications. Then we took a little bit of a side quest from Chef Claude and learned about some different state management strategies, different ways that we can architect our app, and the pros and cons of each of those ways. We'll actually be getting a chance later on in this course to revisit this topic of where state should be held and controlled. I know I've said finishing the other sections were huge accomplishments, but believe me when I say this is the biggest accomplishment yet. We covered so much ground that you would really be doing yourself and the community a disservice if you didn't go over to the Scrimba Discord community and post an awesome celebratory message in the Today I Did channel. You worked really hard in this section, so you deserve some praise. Now, we have one more section in this course that will be focused on learning new topics, and then we have a couple really fun projects lined up after that. Once you've had a chance to do a little happy dance and to rest your brain for a little bit, let's keep moving forward. Welcome to section 4 and the last section where we'll be focusing on learning new things in React in this course. This entire section is all about how we can handle side effects in React. And in the years that I've been teaching React, I have found that understanding side effects in React can be one of the more tricky things that even seasoned React developers can experience. When React transitioned away from class components into functional components and started using hooks back in version 16.3, the way that the world thought about React kind of changed forever. There wasn't nearly as much talk about side effects in React as there is these days, which once you understand the concept of side effects, actually turns out to be a good thing. Let's take a quick look into what we'll be learning in this section. We've already learned about the new way that React handles forms, with form actions and some other APIs that are a bit outside the scope of this course. However, there are instances where you may still want to do forms in the way that they used to be done in React, which is using controlled components. The app that we'll be building in this section, which we're going to talk about in a second, uses controlled components, and so I figured this would be a good opportunity to cover that topic. Then we'll be taking a bit of a studious aside to talk about functional programming and how the React philosophy has really centered around functional programming. This will give us a better understanding of the concept of side effects and how we can best think about them in React. Then on a more practical level, we are going to be creating a side effect so that we can fetch some data. There's a lot of different ways to deal with fetching data, but we will be seeing how we can fetch some data as soon as our app loads. Then for the majority of this section, we will specifically be talking about side effects, what they are, how we can create them in React, what pitfalls we need to be on the lookout for, and so forth. And of course, this wouldn't be Scrimba if there weren't a ton of hands-on challenges along the way. Speaking of which, to drive this curriculum forward, we are going to be building a meme generator. It's a pretty straightforward app. It has an input for top text, so when you type into this top text input box, on every keystroke, the text on the meme image will update. And then, of course, the same for the bottom text. When you type into this input, the bottom text will update on every keystroke. And then you have the option to click a button, which will get a new random meme image from a list of popular meme images that comes from the meme API called ImageFlip. We'll also have a quick chance to apply the concepts that we learn in this section to add a feature to our Chef Claude app from the last section. So no more delay, let's jump right in. To help us guide our discussion about side effects, we are going to be following this meme generator project. And unlike the previous projects where I actually have us start it completely from scratch, we are going to be beginning this one from a starting point. So before I just threw you into an unfamiliar code base, I wanted to walk through the code here and give you a chance to walk through it yourself. I think it's helpful to have somebody explain the code, but I think it's even more helpful to take the time to go through things on your own and maybe even try to change things. Fortunately, the starting point for this app is really straightforward. We can start over here in our index. We're just creating a root and rendering the app component. The app component is simply importing the header and main components and rendering those. The header is simply this purple header up top, and the main is, well, everything else on the page. The header is as simple as it might seem, and the main is currently not doing anything React-y other than simply rendering the JSX. You can see we're hard coding the image, the top text, and the bottom text. The one thing that is a little bit different about this, and we're going to be talking about this soon, is how the inputs kind of look like they belong to a form, and the button kind of looks like it submits that form. But the truth is, that's not exactly how this one works. The user will simply type into the top text input box, and that will, every keystroke, update the text that displays on the image, up at the top, of course. The bottom text does the same for the bottom, and clicking the button doesn't submit any form anywhere, it just randomly gets a new meme image. This project will be a little bit on the simple side. I know a lot of memes these days have text in different positions than just the top and bottom, but we're not going to get that deep into it. As I said, everything is just hard-coded right now. In the next lesson, we're going to be moving this into React State, and then we'll jump into building this project. And the main reason we're doing this project is learning how we can make fetch requests to an API as soon as our app loads. Before I just jump into the next lesson, I'm going to put a pause in here to give you a chance to look through this code, make sure you understand what's going on. Again, it's not terribly complicated. It's kind of just like walking through some HTML, but doing so should hopefully prime you to have success through the rest of this project. So take some time now to peruse through the code. All right, hopefully that was helpful. In the next lesson, we are going to move some of this information into state. All right, let's get started right off with a challenge. I want you to move the hard-coded meme information that we have down here into React State. The state should contain an object that has a top text, bottom text, and image properties, and then set the initial values of those properties to the values that you see below. In fact, you know what? I'm going to make a change here just so that it's clear. This is an image URL. At this point, we're not going to worry about hooking up the inputs or the button, so you're just simply creating state and using that state value instead of the hard-coded ones down below. Go ahead and get started on this challenge. All right, let's go ahead and create, let's call it meme and set meme, and this will be equal to react.useState. And I need to, before I forget anything else, import React from React. And actually, you know what? We've had 3 sections where we're importing the entire React library, and I mentioned specifically that it makes it a little bit easier to know that useState is coming from the React library, but I think you probably get it for now, so I'm just going to switch it up. We're going to destructure useState and pull that in from the React library, and then just call it useState like this. Honestly, this is probably the more common way that you'll see it, so I think it'll be good to see it both ways. All right, my initial state is going to be an object, as it mentions down here, and we're going to have a top text property, a bottom text property, and I'm just setting these equal to empty strings for now. We're going to fix this in a second, and then an image URL property. Okay, for the top text, we have one does not simply, and right there, bottom text, walk into Mordor, and let's grab this image URL. As our starting point here, clean up the challenge text, and we need to switch these to now use the state value instead. So this is going to be meme.imageURL. This one is meme.topText and meme.bottomText. These kinds of refactors are not super thrilling because I will hit save and it essentially looks like I didn't do any work. But we've primed ourselves to now be able to update our state, which will, of course, update the UI. This whole section is about side effects and using a built-in function from React called useEffect, but I kind of want to take care of some of the other items that we have. For example, being able to type into these inputs and have them on every keystroke update our text. So I guess we have, pun intended, a little bit of an aside to take before we get into side effects. So in the next lesson, let's hook up these inputs so that they can update our state. In the last section, we learned all about forms and how we can add an action property to our forms in order to catch the information whenever that form gets submitted. I mentioned at the time that that represents an update to React. This is something new in React 19 that is very, very welcomed. Before this update, we had to use something called controlled components whenever we created a form. And truth be told, I think it was one of the worst parts of React. It was overly complex. It felt like it was reinventing the wheel. And with that glowing review, we are going to start using controlled components. Don't get me wrong, there are still instances where controlled components make sense in React, and we are about to see one of them. Remember, with our two inputs here, we aren't collecting information from the user and then submitting it somewhere for it to be processed. That's really what a form is intended for. Instead, we just want every single keystroke that the user types into our inputs here to update immediately on the page, which means every change of the inputs is going to update our local state. As such, we don't need to use the underlying ability of forms to maintain and hold their own information and then submit it all at once in a form data object, but rather we want to set it up so that we have an event listener on our inputs, let's see, this input and this input, that on every keystroke or change of the input, we want it to update our state. Now, I thought about doing a whole aside and giving you a series of challenges for this, but truth be told, because with React 19 we have form actions and a couple other slightly more advanced hooks that we were given to deal with submitting forms, I'm actually just going to walk through this and hope that it makes as much sense as possible. Again, this is not the crux of our section, which is supposed to be talking about side effects. First, let's see the onChange event listener working. So I'm going to add an onChange event listener, and I'll call a function, which I haven't created yet, called handleChange. Whenever the change happens, let's create this function, handleChange, and I'll just console log changed for now. Let's hit save. I'll click into the box. Let me open the console. I'll click into the box and I will type some characters. Okay, you can see every single keystroke, spaces, letters, everything, it called my handleChange function. Okay, well, how is this helpful to us? What I can do is I can look at the event that comes through on my handleChange. Since this is an event listener, the value passed to that function is information about the event that was fired. I can grab whatever text is currently in this input box off of the event and then set my top text or bottom text. We're going to see how to do both. I can set the value of that text equal to whatever the input box currently says. So from this event, I'm going to pull off a value. And I'm just going to destructure it right off the event. We're going to get the actual value from event.target. The event is the event that was fired. Target is the element that fired the event. And actually, there's another one. You know what? I think I'm actually going to use current target. You don't need to worry at this point the difference between the two. The point is, I'm going to console log my value. We'll hit save, and I will type into the input box again, and you can see in our console, the first character I typed, it logged the value, which was just the letter T, then TY, TYP, TYPE. Every keystroke is now being logged to the console. Okay, well, I think this is probably a good point at which I can get your hands on the keyboard and give you a challenge. This challenge is only going to partially solve what we're working on, but it'll be a good way for me not just to be droning on. Okay, your challenge is to update the top text value in the meme state object, this one right here, every time the top text input box is changed. Now, for now, I don't want you to worry at all about the bottom text. In fact, I removed the onChange event listener on the bottom text input box, just so it wouldn't be confusing. This challenge will harken back to how you can update a single property in an object's state. So if that's feeling a little bit rusty for you, you may want to open up the lesson in the last section where we went over this. Or of course, you could ask in the Scrimba Discord for some help, or just plug it into Google or ChatGPT, and you should be able to find an answer pretty quickly. All right, your time to shine. Go ahead and get started on this challenge. Anytime we want to update state, we need to use our state setter function. So I'm going to call setMeme. And because we don't want to erase all of the other properties of our meme, we do need access to the previous version of the meme. So I'm going to use a callback function. And what I'll return will be an object. But because I'm inside of an arrow function, I need to wrap that object in a set of parentheses just to be a little more confusing. We'll bring in all of the properties from the previous meme, and we'll change our top text to be whatever value is currently in the input box. Let's clean this up, hit save, and we'll say, shut up and take my money. Cool, awesome. On every keystroke, this was updating. And because React is so good at what it does, it was updating really quickly. There was really no delay in every keystroke for having it re-render and display the new text. Okay, I think we've bitten off quite a bit in this lesson. We're going to learn how we can make our bottom text input box also work without having to write an entirely separate function for it, as well as learning one little gotcha when it comes to controlled components and what the term controlled components means in the first place. All of that's coming up next. All right, what even is a controlled component? Well, remember how I talked about that forms have their own ability to hold their state internally? I mean, we can see that when I type into my bottom text form, this is some text, this value is being saved somewhere. It's being rendered to the screen by the browser, and that's because forms have an intrinsic built-in ability to hold this data. In this case, React is not controlling the output of this form or the actual display of this form. A controlled component, on the other hand, is one that React is in control of. Me changing this text doesn't change anything else on the page. So an uncontrolled component is, for example, an input box that React is not in control of and doesn't reflect the current value of state. And a controlled component is one that React is in control of and does reflect the current value of state. The idea when React was kind of in its early stages, actually just up until very recently, the idea was that React should hold the single source of truth for anything that is being displayed on the page. So text like this that didn't conform to using state in React felt a little bit like an anti-pattern, I guess, in the theory of React. All this means is that, as we can see, I'm able to type something different in my input box than what the bottom text is supposed to be according to React. I have two different versions of truth. In order to make this a controlled component, there are two things that I need to do. The first is I need to be able to update state every time there's a change inside of my input box. This is exactly what we did by adding this onChange event handler in the top text input box. However, there's one more part to this, and that is that the current display value of our top text input box doesn't reflect what the top text state says. It kind of looks like it because our placeholder is actually the same thing. Let me actually change this to something different, and I'll hit save. Okay, you can see something different is correctly displaying in our meme, but both of our input boxes are empty. Again, they don't really look empty because of the placeholder. I guess that was a little bit confusing. But in a true controlled component, we want to manually set the value of this input box equal to whatever the current value is in state. In our case, it would be meme.topText. So now we can see the input box actually reflects the current value of state by saying something different. The two sources of truth have been united into one. It's just held by React. And I can change this, and whatever changes in the top text input box will change on the page as well. So those are really the two parts when it comes to having a controlled component. We need to have the component or the input box accurately reflect what the current value of state is, and also every single change will update that state. And as such, React now has essentially kicked the form's ability to maintain its own separate state internally to the curb, and it's taking control over everything. It's kind of like being a control freak in this case. In our case, because we want the state to update on every keystroke, it actually makes sense for us to use a controlled component here. So let's do the same thing for the bottom text. We're going to give it a value of meme.bottomText, and I'll also copy this on changeover. At first glance, it might look like we kind of have to use a second function because right now we are hard coding that this handle change function will change the top text. In fact, if I hit save and then start changing this, we can see we start to get some weird errors happening because there's a little bit of fighting happening between these two values. Oh, well, and I guess I'm displaying the bottom text value, but I'm trying to update the top text accordingly. Fortunately, instead of having to create a completely separate function, I can use the name value that each of my inputs have in order to correctly update which portion of state I'm going to change. By the way, I know that we're moving kind of quickly here. My old course had probably 6 straight lessons on controlled components and different kinds of inputs, but with React 19 kind of making that mostly obsolete, I really just wanted to fly through this. So I'm sorry if anybody is feeling a little bit lost. That's really okay because, again, we're here in a section about effects. I want to get to learning about side effects as quickly as possible. Here we're pulling in the value from event.currentTarget. I can also pull in the name property. That's exactly this right here, name of either top text or bottom text. And by ensuring that bottom text is spelled exactly the same way as the bottom text property in our state, instead of hard coding top text here, I can use a set of square brackets and say whatever name is currently changing the input, that's the property on the state that I want to update. Again, it's okay if that makes no sense at all. Let me hit save. I don't want this to say something different. Let's have it say one does not simply. We'll hit save again. Okay, so I can start to change this one. Great, one does not. And then we'll just go ahead and change this. And look at that. It's correctly reflecting the respective pieces of state depending on the name property from each of the inputs. All right, geez, that was quite a whirlwind. As I said, that's not really the important part here. We have part of the core functionality working with the top text and bottom text. Now, finally, let's dive in, start learning about side effects in React, and see how that even applies here to the meme generator project. The next task that we have in our meme generator app has to do with fetching some data. You see, we could hard code all of the memes that we want to include as possible images that we get when we click the Get a New Meme Image button, but that's not as fun. We want to use an API that has the currently most popular meme images in its database. And we're going to be using an API called the ImageFlip API, which has a dedicated endpoint to give us 100 of the currently most popular meme images. In order to get those, we are going to have to make a fetch request to the database with all the meme images. Our site will make a request out there, and because it's asynchronous, we don't know exactly how long it's going to take for it to respond, but eventually a response is going to come back to our React app, and we are going to store the array of meme images in our local state in the React app. Then from the array of meme images that we got back from the database, we will randomly choose one every time the user clicks the Get a New Meme Image button, which means clicking the button itself isn't going to be making a fetch request and returning a response, but instead simply loading up the app will have the side effect of grabbing that array of data from the ImageFlip API. Then everything else is just going to be processed locally within our app, like randomly choosing an item from that array of 100 meme images. So if we're not kicking off a request when we click the button, I want you to think, when are we going to be kicking off this first request to get all of the meme images? Well, to be honest, I think I gave the answer away in something I said earlier, but we're going to grab all of these meme images as soon as our app loads. And describing it that way makes it sound like it should be really easy. In the end, it really is easy, but it requires us to have a basic understanding of the functional programming paradigm, how that relates to React, and how we can initiate this initial request upon the loading of our app for the first time. So just to help us have a greater understanding of what a side effect even is, we're going to take a really high-level overview at a programming paradigm called functional programming. I'll caveat this lesson by saying that I am definitely not an expert in functional programming, but I think a really high-level overview of functional programming will be helpful in understanding a little bit more deeply how React works and what the philosophy behind creating React was. It's also going to help us when we're talking in terms of side effects, which is what we're currently working on in our little side quest here. There are a number of main principles with functional programming, and we are just going to be touching on a few of them. The first one that I want to talk about is the concept of pure functions. A pure function is one that if it's given the same inputs, it will always produce the same outputs. And running that function will never have any kind of change elsewhere in your system. This is where the concept of UI as a function of state comes from. All it simply means is that the whole job of your components that you're writing are to take input, which in one example might be incoming props from some above component, and given those props, its entire purpose is to return a user interface, some kind of DOM elements that display on the screen. And if it's written correctly, no matter how many times your app component is rendered, if the props are the same, then the UI that's produced will always be the same. Now, if the props that are coming in exist in a parent component and that component changes those props somehow, maybe those props are actually part of state in that parent component, then the change in props will cause our app component to re-render and potentially produce different results in the user interface. And this exact same principle applies if what changes is an internal state change to our component. Changing that state will then produce a new user interface. And as long as that state changes the same, it doesn't matter how many times your app component re-renders, it will always produce the same user interface. And we talked early on about how React is in charge of doing all of the nitty-gritty behind the scenes, and we as developers just get to worry about making sure that our state or our incoming props are being represented correctly so that what React produces in the user interface is, well, represented correctly on the page. As such, it's really important that the code inside of our components is pure. In other words, it doesn't change anything outside of its own system. And this leads us to the next main principle, which is immutability. And we've talked about this. If we have a component that's receiving props, it's very important in React that we never change those props to anything else. Otherwise, doing this means that our props are mutable, and in functional programming, and especially here in React, props are immutable. The truth is, state is also considered immutable, which might seem a little weird because we have been changing state quite a bit throughout this course, but all it means is that we're not going to be directly mutating state. We're not going to change state equal to something else. We will always use the setter function that we receive with useState in order to make any changes. In the end, what's really happening behind the scenes is it's not just setting state equal to something different, it's replacing that state with a completely brand new version of it, which then causes our entire component to rerun with that new version of state. Feels a little bit like splitting hairs, but it's an important thing in React to understand that immutability is key. Lastly, and this relates quite a bit with the first one of pure functions, but hopefully ties in our main concept here, is that our components in React should avoid side effects, which just means that if we are going to run our app component or create an instance of our app component like we do here, then we need to make sure that it will not affect any kind of outside system. Imagine, if you will, every time I ran this component, it made some sort of post request to add an item to a list in a database. This would prove pretty problematic because if React needs to re-render our app component, I don't know, hundreds of times, if every time it did it, it was adding something to a list in a database, you probably understand why that's a bad thing. We could really end up with major outside problems if we were to allow our components to do anything like this. Okay, so where does that leave us? Well, we are going to discover that side effects are still kind of an important thing for us to have in our web applications. We want to be able to mutate data in databases and do things like add values to local storage or subscribe to WebSocket connections. And so we need a solution in React that allows us to avoid side effects as much as possible, but also to escape from that paradigm whenever it's necessary so that we can keep developing what we need to build. So this leads us into the conversation of how we can deal with side effects in React. A really common thing that you will need to do in your React applications is to fetch data outside of your own React app. And in order for us to fetch that data and then display that information on our page, we need to perform at least two steps. First of all, we need to fetch the data or get the data. So we'll call this step number one. And for number two, we need to display the data, which requires us to save the data in state. First, we'll see what might seem like an intuitive way to do this, and then we're going to find out quickly why that's not quite the whole story, and we'll have a pretty major bug in our component. I'm going to be using data from the Star Wars API. It's just a simple API that can return information about the Star Wars universe, and we'll save that in state and display it just as a JSON object. It's going to look more or less like this with a bit more information. This is just stringified and hard-coded, this object, but we'll replace that in a second. Okay, well, we'll take this naive approach first. We'll go ahead and fetch data from the Star Wars API. This is the endpoint we can use to get the character in the Star Wars universe with the ID of 1, which happens to be Luke Skywalker. And then fetch returns a promise, so we'll go ahead and resolve that promise, which will give us a response back. The response contains a bunch of extra information, metadata about the response itself, the body of the response, and so forth. That body, in this case, is coming back as JSON, and so I can pull the JSON out and turn it into a JavaScript object. And then I can get that data, and what I usually like to do is just console log it to see what it looks like. Okay, let's clean up our notes here. Let's hit save, open our console, and okay, we got the data in. Everything seems to be great. All right, well, let's say instead of calling this generically state, let's say this is Star Wars data, and we'll go ahead and set the Star Wars data. And actually, I've had a lot of talking in these last few scrims, so let's give you a challenge real quick. All right, this isn't practicing anything new per se, but I do want to get your hands on the keyboard as always. So instead of console logging the data, I want you to save it in state and then display it to the page. Essentially, you'll just be replacing this hard-coded object with the data that is saved in state. For anyone in the know already, yes, this is not the correct way to do this in React. We're very soon going to see a problem that we'll run into. But for now, I'll put in a pause and have you work on this challenge. All right, well, instead of console logging the data, let's go ahead and call set Star Wars data with the data instead. And we'll go ahead and replace this object with the Star Wars data. Let's clean up the challenge text. We'll hit save, and it started as null. You probably saw that pretty briefly, and then it replaced it with the object. Awesome. So what's the problem, Bob? This seems like it's working great. Well, we can highlight what the problem is by adding in some code here. Let's just put in a console log that says rendered. And keep in mind, any code that we have inside of our component is going to run anytime this component renders by React. So let me go ahead and hit save, and we don't even need to open up the console to see that we are stuck in an infinite loop. We didn't notice this happening behind the scenes, but all of the code, including this fetch request that we were running, was happening many, many, many times in the background. Let me comment out this rendered just so it stops displaying that to the page. But even though we're not seeing the rendered console log multiple times, there is this fetch request happening infinitely in the background. In fact, I'm going to comment this out so that we have an opportunity to talk about it. Okay, this one's going to take some critical thinking. I'm going to put in a pause here, and I want you to think about why it is that we are stuck in an infinite loop if we have this fetch request uncommented. Think back to everything that you've learned about how React deals with state, how it decides what should get displayed to the screen, and how it decides whether a component should be re-rendered or not. So take a minute to see if you can figure out why we were stuck in an infinite loop. When we had our fetch request uncommented and the component rendered, it ran through the code here. It performed a fetch request, or I should say it kicked off or started a fetch request. Because the fetch request takes some time to complete, it then came to this return and displayed this null on the page because we initialized our Star Wars data as null. Then in what probably feels like an eternity to a computer, the response finally comes back. It pulls the body of the response out and changes it into a JavaScript object. And then, most crucially, it sets that data to local state. What is it that React does when we change local state? If we change local state, React will re-render this component. It needs to display the most updated version of state to the page, so the component has to re-render. However, when we set Star Wars data and we re-render this component, a new fetch request gets kicked off. When that one completes, it sets the Star Wars data, which re-renders the component, which calls a fetch request, which sets the Star Wars data, which re-renders the component, and we get stuck in an infinite loop. Now, I haven't hit save since I uncommented this, so this fetch request is not currently happening in the background, but I'll just pre-warn you, if you do want to play around with this code, if you hit save, it's going to start kicking off this fetch request, so just be aware of that. So how do we avoid this problem with how React deals with setting state and re-rendering if we want to include a fetch request that only happens one time? Well, this is the natural next step in our discussion about side effects, and specifically a hook that React gives us called useEffect. So let's dive right into learning useEffect and see how it can help us solve this problem that we're facing. Let's kick off the discussion about useEffect by looking once again at what React's primary tasks are. As we've discussed, the main thing that it's in charge of is working with the DOM and the browser in order to render user interface to the page. Very helpfully, along with that, it's going to manage any state for us between render cycles, which gives us developers a way for a value to be remembered from one render to the next. And because we have state and we have props, React is in charge of updating the UI. Once again, kind of like we talked about in the first point, it will update that UI whenever the state or the incoming props change. There's a lot of other things that React, of course, is doing behind the scenes, but I think it would be fair to boil down all of the very detailed things that it does to these kind of main tasks. Well, this naturally leads us to ask, what can't React handle on its own? And primarily, React can't really do much regarding outside effects. Some examples of this are interfacing with local storage. If we're relying on a value from local storage and that value changes one way or another, React isn't automatically going to update itself based on the changes from local storage. I guess let me also be clear about local storage and the rest of the items in this list. I'm not saying you can't use these tools with a React application. I'm simply saying React isn't automatically connected to them. And so we need to connect these things manually ourselves. Another example of an outside effect that React doesn't automatically connect to is an API or any kind of database interaction. We need to manually call out to an API and receive the data that comes back in order to then display it on the screen. This is exactly what we were doing with the Star Wars API. Along that same vein, anything dealing with subscriptions like a WebSocket connection, React doesn't automatically know how to connect to outside systems or what to do if data were to come in and change, and so we need to take that into account as we're writing our code. Essentially, this could just be boiled down to basically anything that React isn't in charge of, which is what we saw in the last slide. So how can we deal with these outside effects? Well, that's where the useEffect hook comes in. Whereas it's really important for our React components to be pure components and follow some of those principles of functional programming that we talked about earlier, useEffect gives us a way to sort of create an escape hatch. In fact, escape hatches is exactly what the React docs talk about. You can click on the screenshot here to go to this page talking all about escape hatches. This goes beyond the scope of just useEffect, but if you scroll down to this section, which says synchronizing with effects, it will talk about useEffect a little bit. Feel free to read through this sort of as a reading the textbook before class sort of thing. And once you're ready, we're going to jump into the syntax of useEffect. Let's learn how we can apply the useEffect hook to fix the issue that we were having with our Star Wars data re-rendering this component in an infinite loop. Before we get started, I want to give you a chance to go check out the useEffect documentation. The screenshots that I had given you before talked more about how to use useEffect. This one actually gives you the real syntax, and so this would be a good chance to go check out the documentation before running through the rest of this scrim. We can see from the signature here that there are two parameters that we need to pass to useEffect. The first one, it calls setup, which turns out to be a callback function. And the second parameter is optional. That's what the question mark here means. And it's an array of dependencies. In this scrim, we're going to talk about the setup callback function, and in the next one, we'll talk about the dependencies. So let's come back to our code, and if I uncomment this console log and hit save, we can remember that we are stuck in this infinite loop of rendering, and the reason is because of this set Star Wars data line, which is causing a re-render of our component, which is kicking off a fetch request, setting Star Wars data, and so forth in the infinite loop. Let me just comment out this line here and hit save. That will stop the infinite re-rendering for now. useEffect is a function that we can import from React in a very similar way that we were doing with react.useState. We can call react.useEffect. And as I mentioned, there are two parameters. The first one is going to be a callback function. Now, almost exclusively these days, you'll see this written as an arrow function like this. But just in an effort to make this completely transparent, I'm going to put an inline function declaration like this, and then we'll switch it back for an arrow function later. I think having the function keyword here makes it much more apparent that we're working within a callback function. What useEffect allows me to do is inside of the code of this callback function, I can put any code that is going to have some kind of side effect outside of the React ecosystem. In the case of our fetch request here, where we are trying to get data from an outside system, this would be the correct kind of code to put inside of a side effect with useEffect. More specifically, the code I put inside of this callback function is the code where I want to synchronize data from an outside system with our internal React state. Now, I have a confession to make, and that is that if we were to uncomment this setting Star Wars data line and hit save, we're going to see that we are still stuck in an infinite loop. So what went wrong? How come our useEffect didn't solve everything? Let me actually go ahead and comment out this line again. So on its face, it would seem like putting this code inside of our useEffect made really no difference. And the truth is, without the optional dependencies array, which we're going to be talking about in the next lesson, that's kind of true. There is one minor difference that I think is important to note at this point, and that is that any code you put inside of this callback function is guaranteed to only run after React has mounted your elements to the DOM, or in other words, painted the elements from your component to the page. We can get a glimpse into this if we were to console log maybe effect ran here inside of our callback function. We'll hit save. We can see we first get rendered and then we get effect ran. And the truth is that has nothing to do with order. If I place this console log below that one in terms of where it sits on the page, we're still going to get rendered first. And that's because it's running through this code, reaches this console log, runs this console log, renders the elements to the page, and then runs our function inside of our useEffect. So that's kind of a slight difference between just having this code sitting outside the useEffect, similar to our console log here. But for our purposes, when we uncomment this line, we're still going to be running this effect function on every single render of our component. So let's dive in and talk about that dependencies array and see how it's going to help us solve this problem. I've made a small tweak to our little sample app here, and that was to add this counter and a button to increment the count. And of course, I changed this to dark mode for any of you who felt blinded by the last example that we had. The only reason I added a counter was so that we had a really easy way for us to force React to re-render this component. We can see in the console that the first time we load this up, we get the rendered console log here, and then we get our effect ran console log as well. If I go ahead and click the add button, we can see we get both of those console logs running again. This shows us that the useEffect callback function we have is running on every single render of our component, which is why moving this set Star Wars data line inside of the useEffect didn't solve our problem. However, what we'll learn about now will solve this problem, and that is the second parameter that we can pass to the useEffect function. If by default, the first parameter, this callback function, will run on every single render, the second parameter gives us a chance to stop it from running on every single render if we want it to. And in practice, you pretty much will always want to include this dependencies array. I can't think of too many times when you would want your useEffect functions to run on every single render. So what exactly goes here? Well, it is called a dependencies array, so this will always be an array of values that React is going to watch between one render and the next. If any of the values in this array change between those two renders, then React will know that it should run this function again. So let's play with this for a second. Let me go ahead and put the count value that we're tracking in state as a value inside of my dependencies array. I'll click save. We can see we got rendered and effect ran. So now we know that this effect will run on the very first render of the component. And let me click the add button, and we see we got rendered and we got effect ran again. Let's dive even deeper and see what happened behind the scenes. The very first time this component re-rendered, I'll hit refresh now so we reset our count to 0. Count here was evaluated as the value of 0. Our console log rendered ran, React then painted this div and its child elements to the page, then it ran this effect function. And behind the scenes, it's storing this array with the value of 0 so that it can compare the dependencies array on the next time this happens. So I go ahead and click add. Now what happens? Well, this count value, which remember it's saved as count, React incremented the count from 0 to 1. It painted the stuff on the page. And then it looked at this effect function and its dependencies array. And this time the dependency count had a value of 1. And so behind the scenes, React was looking at what it used to be the last time this effect ran, which was an array with a 0 in this first index here, or I guess the 0 index. And then it compared it to what it currently has, which is an array with a 1 inside. And the logic of React says, well, it used to be an array with a 0, now it's an array with a 1. These are different from each other, and so I need to rerun this callback function again. So as you can imagine, it's called a dependencies array because this callback function depends on the value that you're putting inside the parentheses here. All right, let's do two things. First of all, I've been kind of changing this value of count. I think it's important for us to remember that this is still a variable. It's not a hard-coded number, but I think that can be a good practice for us. I want you to think what would happen if I hard-coded this as a 0. I'm going to hit save. We get rendered and effect ran. So I'll put in a pause here, click the add button, and try to see if you could explain why it's doing what it's doing. Okay, I'll click the add button, and this time we only got rendered logging to the console, which means that this callback function did not run this time. So what's going on here? Well, because I've hard-coded a 0 inside of my array, the first time our component rendered, it saved this dependencies array as an array with a 0 inside, and the next time it rendered, after we clicked the add button, it compared it to the hard-coded array with a 0 inside. And this time, because these arrays contain the exact same data as each other, React thought, well, I don't need to rerun this callback function because nothing has changed. Nothing that this function depends on has changed. And so I don't need to try and synchronize with any outside system again because nothing has changed. Okay, so that's the first thing. Let's go ahead and set this back to count. The second thing is let's go ahead and uncomment our set Star Wars data. I'll hit save and check it out. We are no longer caught in an infinite loop. I'm going to put in another pause here, and I want you to try and reason through why it is that now that we have this dependencies array here, we suddenly are no longer stuck in a loop when we're setting our Star Wars data. Before, when we were setting our Star Wars data, it was re-rendering our component, which was causing our useEffect function to run again because we hadn't taught it when not to run. Now, our count has not changed. Even though we're setting our Star Wars data and re-rendering this component, which is why we got a second rendered console log displaying, because our count has not changed, we are no longer making another fetch request. So now I want you to think what's going to happen if I click the add button. Well, clicking the add button is going to change my count value, which is going to make it so that between the two different renders, my count value inside my dependency array will have changed, and therefore I will be kicking off another fetch request. So let me click the add button, and we can see that we did get rendered, effect ran, and then rendered again. It's a little hard to tell because the data hasn't changed since the last time, but it did re-render this, and it did make another fetch request. Okay, we are way too long overdue to have you do a challenge, so let me type out a challenge for you. All right, your challenge is to rewrite the useEffect. For now, we're going to have it rerun anytime the count changes, so anytime this add button is clicked. And for now, you don't have to go fetch data from the Star Wars API or anything like that. You can simply console log effect function ran. So give this your best shot, see if you can remember how the useEffect function works. I can create a new side effect in React by using react.useEffect. The first parameter is a callback function. Before, we were using a function declaration like this, although I did mention that the much more common way you'll see this is by using an inline anonymous arrow function. So we'll go ahead and switch to doing it that way for now. I'm just going to copy this effect function ran console log, and I need to make sure to include my dependencies array so that it only runs when the count value changes. Let's clean up this text. We'll hit save. I'll click add, and we got effect function ran a second time. Okay, if this is your first exposure to useEffect in React, first of all, congratulations on doing that challenge. The syntax can seem a little bit weird. But second of all, you might be wondering, why are we putting count inside of this dependencies array? We've learned that the dependencies array can give us some control over when this effect function runs, but it might not seem super apparent why we're putting count in here. And the truth is, we probably shouldn't be putting count in here. So that's what we're going to be covering next. All right, so we've learned that the dependency array gives us some control over when our effect function runs. And we learned that React is going to compare the values inside of our dependencies array from one render to the next in order to determine whether this effect function should run again. So how do we determine what we should put inside of our dependencies array? Well, I think if we take a second to truly understand what values we should be putting inside of our dependencies array, it will suddenly start to click for us. Right now we have this count value in here, and that was simply to show that this effect function will run whenever we increment the count. But if we look at our code, there's no code inside of here that depends on the value of count in order to correctly synchronize with an outside system. Changing count is simply going to call another fetch request to the Star Wars API, which knows nothing about count nor depends on count to get correct data. So let's see what happens if we simply remove count from our dependencies array. I'll hit save. Okay, we can see we got rendered, which is the very first time our component rendered. Then behind the scenes, React put this div and its children on the page, first with an empty array displaying as the data down here. Then our useEffect function ran, and this console log ran, which is why we see effect ran in the console. The fetch request kicked off. It took a little while for the data to come back, but eventually when it did, we set the Star Wars data with that data, and React triggered another re-render. Keep in mind, when it ran this effect function, it looked at our dependencies array, which was an empty array. Let me go ahead and type this down just in a comment here. So this was on the first render. It had an empty array. Set Star Wars data triggered a re-render. It did the whole re-render thing and placed the new information on the screen with the correct Star Wars data. Then it looked at our dependencies array this time around. And what it did is it compared an empty dependency array to another empty dependency array. When it saw that nothing in these arrays had changed, because there is nothing in the array, it said, I don't need to rerun this effect, because nothing that this effect depends on has changed. And because we've removed count here, count is also not something that this code depends on. So if I click add, I'm simply going to get rendered every time, and the effect is not going to run anymore. All right, well, we've learned quite a bit of stuff. What I'd like to do is in the next couple lessons, I want to first do a quiz that we can talk a little more high level about what useEffect is helping us with. And then we're going to have just a small series of challenges to give us some more practice in understanding useEffect. All right, it's quiz time again. Just like before, read through these questions, click into the editor, and type down your answers. For question number 1, it's been a little bit of time since we talked about functional programming and pure functions, so don't hesitate to open up that lesson on functional programming in another tab or something and review that before answering this question on the quiz. So go ahead and answer the questions in this quiz. Okay, number 1, in what way are React components meant to be pure functions? And actually, I'm going to pull up my old slides on this one right here. The idea of the pure functions was to say that a component, when it's given certain props, should always return the same user interface. And the same thing holds true of a state change or any internal state in the component. Given the same state values or the same props values, it should always return the same user interface. And so that's the main idea of pure functions in React. So given the same props or state, a component will always return the same content, or the same UI that gets rendered on the page. Another aspect of having pure functions in React is that rendering your component, or running that component function, will never affect any kind of outside system. We talked previously and imagined a scenario where maybe our component, every single time it rendered, were to add an item to a list in a database. This would be very blatantly not a pure function because every time it runs, it adds a new item to a database, which means we are very much affecting an outside system. So that's just another important aspect of having pure functions in React. That leads us very naturally to what is a side effect in React and what are some examples. Well, really, a side effect is any code that affects, or we could even say interacts with, an outside system. It's a little nuanced, but even doing a GET request to an API is considered a side effect, even though we're not really making a change to that outside system. Simply interacting with the outside system makes it a side effect in the realm of React components. Some examples of this might include interacting with local storage, anything dealing with an API or making a connection like through WebSockets. One we hadn't really talked too much about was doing any kind of manual DOM manipulation. All of these are services or systems that exist outside of React, and so interacting with them inside of your components is considered a side effect in React. So number 3, by contrast, what is not considered a side effect in React, and what are some examples? Well, in this case, it's really anything that React is in charge of. Some examples of which are maintaining state, keeping the UI in sync with whatever data you're working with, rendering DOM elements, and certainly there's a lot of other things that React is in charge of, but all of those would be considered not side effects in React. All right, number 4, this is kind of the meat of this quiz. When does React run your useEffect? Well, it will always run your useEffect code as soon as the component loads, or let's say renders. And more specifically, it's when it renders for the first time. This most commonly happens when you first refresh your page or launch your app and it gets loaded into the browser for the first time. Although it could also be if you were conditionally rendering something and it was not present on the page before, but then some state value changes and it becomes present on the page. That would be considered the first render for that component. React will also run your useEffect function every time a component re-renders, assuming you have no dependencies array. So on every re-render of the component, assuming no dependencies array. And maybe to answer this next one, when will it not rerun the effect function? Well, that's going to happen if between renders, the values in the dependencies array have not changed. And lastly, how would you explain what the dependencies array is? Well, spoken more literally, it's the second parameter to the useEffect function, but more importantly, it's a way for React to know whether or not it should rerun the effect function. I know it probably feels like I'm beating a dead horse with this useEffect thing. The reason I do this is because I do find that useEffect tends to be the most confusing topic in React, not only for beginners, but is widely misunderstood by even seasoned veterans in React. I really want my students of this React course to come away from the course having a pretty solid understanding of useEffect, when to use it, when not to use it. And so we are going to have a short series of challenges that we'll do to help us really drill in useEffect, as well as another aspect of useEffect that we have yet to learn. Along the way, we're also finally going to come back to our meme generator so we can apply what we've learned regarding useEffect to that app. All right, in order to get our repetitions in, the first part of your challenge is to write our useEffect from scratch. I want you to fetch the data from the URL that is right here and save it in the Star Wars data state. While you're doing this, make sure you don't get stuck in an infinite rendering loop like we did before. Go ahead and get started on the first part of this challenge. I'm going to copy this URL and then just get rid of this challenge text, and in its place, we will call react.useEffect. I'll put a callback function as my first parameter. And before I forget, I'm going to put my second parameter as an empty dependencies array. We'll revisit this and determine whether or not we need to add anything to that dependencies array. What I want to do is fetch the URL that I copied. We'll say .then, we'll get the response, and we'll pull the JavaScript object out of that. And then we will take the data that we get and we will set Star Wars data with that data. Now, before I hit save, I want to think to myself, anytime I'm creating an effect, what does this effect rely on? Are there any values that I need to make sure I include in my dependencies array so that if that value were to change, I might need to fetch new data or do some other kind of interaction with an external system? And in this case, no, none of the values that I'm using inside of my fetch request rely on anything outside. I just want to get the data that lives at this URL. So by putting an empty array, essentially it's like saying, I just want you to do this fetch request the first time you mount, and then you won't have to do this fetch request again later. We'll hit save. We start with an empty object very briefly, and then the data comes in and we fill it in with the data from the Star Wars API. Okay, that should have just been repetition there. The next challenge we do will expand upon this a little bit more. Okay, I've made a couple really small changes here. First of all, I'm beginning my count value at 1, and secondly, I've changed the text of the button to say get next character. Notice that the URL on the Star Wars API says /people/1. Well, this /1 is the ID of a character in the Star Wars database. And if I were to do 2 or 3 or 4 or 5, I would get new characters being returned to me through my API request. So what I want you to do is to combine the count value, which has up until now been kind of a silly way just for us to trigger re-renders, and make it so that when we click the Get Next Character button, it will change this 1 to a 2 or a 3 or a 4, whatever the count currently is, and get new data for that new character. While you're doing this, remember to consider your dependencies array, what may or may not need to be in there. All right, go ahead and give this challenge your best shot. Well, the first thing we want to do is not have this one be hard-coded. So I'm going to use a template string and simply replace my 1 with some interpolated value of the count. I did change this from a 0 to a 1 because I don't believe there's a character with an ID of 0. So let me hit save, and we should see that, okay, we're still getting Luke Skywalker because this was set to a 1. If I instead were to hard-code the initial value for my count state to a 2 and hit save, we should get, yes, a new character, C-3PO. Okay, well, we don't want to start at 2. Let's start at 1, and I'll hit save before I make any kind of change to the dependencies array. And let's go ahead and click Get Next Character. Okay, we see that the count is 2, but our data did not update. And that's because our useEffect doesn't know that it should be watching for changes to the count value in order to determine if this function should run again. But we actually are depending on the count value now. Before we weren't, but now it does matter. If count changes, we need this effect to run again so that we can accurately reflect the new information on the screen. So in my dependencies array, I'm going to add my count value. We'll hit save. We get Luke Skywalker, and I'll click Get Next Character, and there it is. We get C-3PO. We can go to the next one, R2-D2, Darth Vader, Leia Organa, and so forth. I really hope this hasn't been overkill, and I hope that useEffect is at least starting to become clear if it hasn't clicked quite yet. The more you use it, and the more, honestly, bugs that you find with useEffect, the more solid your understanding of it will be. As I mentioned, we do still have some more to learn about with useEffect, but it's been so long since we have seen our meme generator project that I think we should go back to that, apply what we've learned, and honestly, I think once we have done that, we'll mostly be done with that project. It was a pretty quick one. So let's jump back into the meme generator with a challenge. Okay, everything that we've been learning about useEffect has led to this moment. The way that we are going to structure this app is that as soon as the app loads, we're going to make a call to the image flip API. And I've included a screenshot of the documentation as well as a link. You can click this screenshot to go to this link, and you'll need this in order to complete the challenge that we have. So the way that this app is going to work is as soon as our app loads, it should make an API call to the image flip API, and it will get an array of memes. So it's not going to be that when the user clicks get a new meme image that it makes an API call, but instead when the app loads, it will get, I think it's like 100 memes. Then clicking the Get a New Meme Image button will simply randomly choose one of the items from that original array of 100 memes that we got when the app first loaded. The only reason that we're doing it this way is because I don't think that the Image Flip API has an endpoint to just get a random meme image, at least not one that's free. So this will work for us for now, and your challenge is to write the code that gets an array of memes from the Image Flip API as soon as the component renders for the first time. Again, you'll need to check the image flip documentation. In fact, I'm going to leave this up for just a second so you have a chance to click here. And when you get there, you'll find the correct URL that you'll need to call in order to get that array of memes. Once you've gotten the array of memes back, you'll need to save it to state so that we can access it from the component in React. At this point, I don't need you to worry about this Get a New Meme Image button. And I do want to give you some fair warning. If you're tempted to use an async await function, I'm going to ask you not to do that, but instead to use .then in order to resolve the promises that come back from fetch. We're going to learn why after this challenge. All right, your time to shine. get started on this challenge to get the array of memes from the ImageFlip API. Well, since we need to kick off this request as soon as the component loads, this would be a great time for us to use useEffect. This is an example of a side effect in React because we want to synchronize our local state from within this main component with an outside system, which is the data that lives at the ImageFlip API. So I've imported useEffect from React, and I can call useEffect here. The first parameter is a function, and because it's the more common way you'll see it, I'm going to use an inline arrow function. And before we write this code, I'm going to immediately start thinking about the dependencies array that I need to include here. So what does our side effect of fetching data from the API depend on in order to make sure that it is correctly syncing the data from the ImageFlip API with our internal state? Well, in our case, it doesn't rely on anything. It doesn't depend on anything in order for that sync to happen correctly. In other words, there isn't any local state that if it were changed, we would need to go refetch data so that it was correct. In our case, we're simply getting a list of 100 memes, and we're going to be using that list for our app. So I want to make sure I include the dependencies array because I don't want this fetch request to happen every single time state changes and the component re-renders, which remember happens every time we type in the input boxes here. So I need to make sure I include this, and effectively this is like saying I only want you to run the side effect one time when the component first mounts. All right, so what do we want to do? We want to fetch. And if we go to the documentation, we can see there is an endpoint called get_memes, and we can find the URL there. And so I'm going to paste it in. It's just this one for the api.imageflip.com/getmemes. And I need a closing quotation mark there. And as I mentioned, for now, we are just going to resolve this with a .then chain. We get a response back from fetch, and we will need to call res.json. That's going to parse the JSON body that we get from making this API call into JavaScript, and we can access that with data. Or this is just a parameter, you can call it whatever you want. Let's go ahead and console log this data. Okay, we'll hit save. I'll open up my console, and perfect. It looks like we get the data correctly. If we look closely, the data that comes back is an object. It has a success property, and I guess confusingly, because we chose to call this data, it has a data property, which is an object that has a memes array. And so that's how we need to dig into this response data to access the array of memes. So again, I guess kind of confusingly, it's data.data.memes. By the way, quick side note, when I hit save, it's refreshing our app, which is kicking off yet another fetch request. However, refreshing your browser is something completely different than just changing state locally. There's a difference between clicking refresh, which reruns all of the code from React, and changing state, where React simply determines what needs to re-render to the page, but doesn't refresh your browser. So that's just why hitting save and refreshing is causing the fetch request to run again. And this time it looks like in the console, we accurately got the array of memes. If I scroll down here, it's pretty long. In fact, it's long enough that it doesn't even show everything here in Scrimba. By the way, if you're following along here in Scrimba, you can open your developer tools, and anything that we console log here will also console log in your developer tools. So that can be a good way to look into more complex items that we're console logging, like this array here. Okay, well, we don't want to console log it. We want to put it in state, and that state does not exist. So we're going to create a new one. Maybe we'll call this, let's call it all memes, and we'll pull in set all memes is equal to use state. And this is going to be an array, so I'm just going to initialize it as an empty array. And then instead of console logging, we'll call set all memes. And yeah, we want to set this array in state. Let's close our console. Since we're not console logging anymore, we can get rid of our challenge text. And actually, I'm going to keep this hint here for now because we're going to talk about that in a second. I can hit save. It's not going to be very clear that this is actually working, but I trust that set all memes is working the way it's supposed to work. So why did I give you this hint that says not to try and use an async await function? If you're familiar with async await, it might have been tempting to say, well, I want to use await for resolving these promises. And so I want to make this function an async function so I can use the await keyword and make this code a little bit tidier. If you're not quite as familiar, it allows you to do something like this, where you say, well, the response is equal to await the finishing of this promise. And in this case, response would also be a promise. So we can say const data equals await res.json. And then we can simply set all memes to data.data.memes like this. This is quite a bit tidier. I personally like using async functions. However, when you're using useEffect, you can never make this function an async function. So before I screw everything up, let me get rid of all this. And in the next couple lessons, we are going to talk a little bit more about useEffect because there is a really important aspect of useEffect that we have not yet had a chance to cover, and understanding it is going to explain why we can't make this into an async function and what we can do to work around that limitation. So once you've had a chance to make sure that what we've done here makes sense, I will see you in the next lesson. We'll start this one off with a pretty simple challenge just to get your fingers typing on the keyboard and make sure you're awake. We have this very simple app that has a button with the text of toggle window tracker, and then we have a window tracker component. Notice that the button isn't currently set up to do anything. That's going to be your challenge. Over in the window tracker component, right now it's just displaying this H1 that says window width, and then it displays the window width at the time that it was rendered. We'll notice that if we change our window width, the display doesn't actually update. But if I were to refresh, we would get a new value of 494 here. We're going to address this a little bit later. For now, though, we can just focus on this first part of the challenge. The first thing I want you to do is to create new state called show and default it to true. Then I want you to make it so that when you click the button, it will toggle that show value. And thirdly, you should make it so that you only display this window tracker component if show is set to true. I'll hand it over to you now to work on this challenge. All right, let's go ahead and create some state. We'll say react.useState, and I'm already seeing I'm going to have to import React from React in order to do that. React.useState is going to give us some values back, so we'll say show and set show is equal to React.useState, and we'll default it to true. All right, and then we need a function so that it will toggle it. I could either do this in line with my button, or my personal preference is to make a named function out here. So I'll say function toggle, we'll call set show. It will look at the previous value of show and just return the opposite. About as simple of a set state function you can have. I'll add the onClick event to my button that calls toggle. And lastly, I need to conditionally render my window tracker so that it will only display if show is true. So I'll go ahead and use the $& method. Let's clean up our challenge text, hit save, and toggle window tracker. Okay, perfect. Now let's take a look at something. If I go to window tracker, remember that this window.innerWidth is being calculated as soon as this component mounts to the page, which in our case will happen as soon as we refresh the browser. So I refresh, we're at 418. If I resize this a little bit and refresh, it recalculates, we're down to 390. However, I also can toggle my window tracker off, change my window size, and toggle it back on, and we'll see that we're at 470. And actually, I don't have to toggle it off first. I can resize it. We'll notice that the 470 doesn't change, but if I toggle it off and then on, we get the new value. So why exactly is it doing that? Well, when I toggle it off, it's being completely removed from the page. I'm not just hiding it from view in CSS or anything, it's actually getting removed from the document itself. And so when I put it back on the page, this window.innerWidth is being evaluated again, and the new inner width of my window is being displayed. However, we can do better than this. If we want this number to display more in a live fashion while I'm updating the width of the window, what we can do is listen for a dedicated resize event on the window itself, and then add some state to our window tracker and update that state with the window.innerWidth every time the window is resized, or rather every time the window resize event triggers. By updating our state on our window tracker, we can have React re-render this component and give us a live view of what the current window inner width is. However, because I need to run this event listener on the window itself, I don't have a dedicated on resize event like we do with other DOM event listeners like we have been using thus far. So in order to add this resize event listener on the window, I'm going to have to do some more manual imperative DOM manipulation. And because I'm going to be interacting with a system outside of React itself by trying to interact with the window of the browser, I want you to think for a second, what tool does React give me so that I can interact with those outside systems and sync the internal state in React with it? That's right, it is useEffect. So I can go ahead and use react.useEffect. I'll put my callback function inside here. And when we try to think about our dependencies array, one thing that can be really tempting is to try and look at window.innerWidth and say, well, anytime window.innerWidth changes, then I want to rerun my effect to synchronize window.innerWidth with the state that we're going to set up in the future. However, something that's important to remember is that window.innerWidth is actually a static value. Right now it's 388, so this would be kind of like me putting in 388 as a hard-coded value here. And then we have to remember that when I resize my window, I'm not telling React to re-render anything. I'm not changing state or doing anything like that, at least not yet. So as tempting as it might seem, putting the window.innerWidth in there isn't going to be the solution here. So let me go ahead and get rid of that. So instead of that, we are going to add our event listener on top of the window. So I'll call window.addEventListener, and the event that I can listen for is actually called resize, and we'll pass a callback function that will run anytime the resize event happens. And for now, let's just go ahead and console log resized. All right, let's hit save. I'll start resizing, and look at that. We get our console log running every pixel, I think, essentially, that the window gets resized. All right, well, the next step is something that I think you should be able to do pretty easily by now, so I will type this out as a challenge. All right, here's your challenge. First of all, I want you to create some state called window width and default it to the window.innerWidth as its initial value. Then whenever the window width changes, you should update that state to the new window.innerWidth. And then down here below, instead of displaying window.innerWidth, you should display the new state that you created so that it updates every time the window width changes. In the end, you can see what we're doing is we're interacting with an outside system by adding a manual add event listener to our DOM, and then syncing our local state to the source of truth, which is the outside system that we're grabbing the window.innerWidth from. By syncing internal state with it, we'll be able to actually display to the user the value from that external system, or the window in this case. All right, it's your time to shine. Go ahead and get started on this challenge. Okay, let's call react.useState, and I'll create the variables that I'm going to save this as. This will be my window width, and we'll call it set window width. We'll initialize this to the window.innerWidth as the initial value. Then instead of console logging resized, I'll call set window width. And in this case, I don't really care what the previous value is. I can simply reset it to whatever the current window.innerWidth is when this event was called. Then lastly, I'm setting window width in state, but I'm not actually using it anywhere, so I will replace window.innerWidth with the state value of window width. Let's clean up our challenge text, hit save, and we'll try resizing the browser, and look at that. Our window width is accurately reflecting on the page for the user to see. Well, now let's take a look at a little bug we have. Remember, our window tracker component is only displaying if the parent component. Great job on these challenges. Unfortunately, I have some bad news, and that is that we have a bit of a bug in this in our code. And the bug exists over in our window tracker, but because this lesson has gotten a little bit long, we are going to talk about the bug and what the main fix is for it in the next lesson. We have a pretty sneaky bug that lives in our window tracker component right now, and it's not immediately apparent what the problem is. Using the app makes it seem like everything is working just fine. We get our window width updating on the page. We can toggle it on and off. If it's off, we can resize and it doesn't look like anything's happening. So what's the problem here? Well, we can highlight it if we were to add a console log back into our resize event. Let's just say resized. I'll hit refresh. If I resize it, I'm going to try and just resize it one little section. I think it'll maybe go by 2 pixels. Okay, so we got a single console log running. Well, let me toggle off my window tracker. I'll do a resize. We'll do a single pixel again. Okay, it's still resizing, even though my window tracker component doesn't live on the screen. Okay, well, what happens if I toggle this back on and off a bunch of times, and then try to resize the browser? Right now we have 2 resized in the console. I'm going to go just a single pixel here, and take a look at that. It looks like we got 7 new resized console logs showing up just by doing one resize event. So why the heck is this happening? Well, remember, useEffect gives us a chance inside of React to interact with or sync state with some kind of external system. In this case, when we're adding an event listener to our window object, this is happening outside of React. I'm registering an event listener with the browser. When I toggle the window tracker off, I'm not giving any kind of instruction to the browser to say, hey, I'm done with that event listener, you don't need to listen anymore. When I toggle the window tracker back on, it's remounting the window tracker component, and in the first time that it mounts, it's adding another event listener. Kind of a silly analogy I came up with. I imagine myself walking into a store, asking a store employee if they have, I don't know, a certain item in stock. By doing so, that employee has to go maybe back into a warehouse to check to see if they have it in stock. And in the meantime, if I just kind of abandon my cart and leave the store, at no point did I tell the worker that, hey, I actually don't need you to do that work anymore. And kind of to stretch the analogy a little bit thin, when we toggled our window tracker on and off a bunch of times, it's kind of like me going from one employee to the next, asking them to go do a task for me, and then just kind of leaving them and not needing them to complete their task. Because we're creating a side effect in React, it's really important that if we reach a point where we don't need to interact with that outside system anymore, like, for example, if we're toggling off our window tracker, then it's really important that we clean up any of the side effects that we have created. In this case, we're adding an event listener. It's going to be important that we remove the event listener. If instead, on the mounting of our component, we had created a WebSocket connection with a server, then it would be important if we unmount that component to disconnect that WebSocket connection. Fortunately, in React, this is a pretty easy task. Remember, when we created our useEffect, we passed a callback function as the first parameter to useEffect. But as it stands, we're not currently returning anything from this function. So you might be wondering, well, what does React do with the value that we return from the function that we pass to useEffect? And as it turns out, what we can optionally return from a useEffect is a function. In fact, just to make it abundantly clear in the syntax, I'm going to use a function declaration like this. So behind the scenes, React is going to call the function that we gave it, and it's going to save as a variable the function that we return from our useEffect callback function. And when this component gets unmounted and React determines that it's time to potentially clean up any of the side effects that we have created in our useEffect, it will take the function that we give to it and it will just run the code. It doesn't know what's in that code, so it's up to us to make sure that we clean up any of the side effects that we created in the first part of our function. With the addEventListener method, there is sort of a sister method called removeEventListener. And in order to make that work, I have to pass it the exact same function that I used when I was setting it up. So in order for that to make sense, I'm going to have to move that function into its own named function. And let's give it a name, maybe watch window width. I can pass this named function to my addEventListener, so that's working again. And then in my cleanup function from my useEffect, I need to call window.removeEventListener. And I'm going to remove the resize event listener that we created and need to pass my watch window width function so that it knows which of the functions it needs to remove. Let's see, we still have our console log in here, so we should be able to test to see if this is working. I'll hit refresh. Let's resize just to make sure we're working okay. Okay, we got 4 of those. That's because I moved it a few times. If I go really slow, I can get it to do one at a time. Let's clear that out. I'll turn off my window tracker and we'll try resizing. Okay, we're not getting our console log. I'll also kind of turn it on and off a bunch of times, and now it's on. Let's try to resize it just by a little bit, and sure enough, we only get the console log running once. So as a recap, because we have an empty array here, we are just calling this useEffect one time when the component first mounts to the page. When we do that, we're setting up an event listener for the resize event on the window object, and it's going to run this function if the resize event ever happens. Then we're returning our cleanup function, which says if this component ever unmounts, just run whatever code I put inside of this function so that I can be sure I don't have any of these side effects just kind of floating around inside my browser. So as long as my component is on the page, this event will work just as we might expect. As soon as it leaves the page, React runs our function, which removes the event listener, and therefore I no longer get my resize console log running. In fact, one last thing that we can do just to see for sure that this is happening is if I add a console log inside of my cleanup function saying cleaning up, when we hit save, we can trigger the resize event like this. Okay, we get resized, and then when I toggle it off, I get cleaning up. So one final recap before we move on. useEffect allows us to interact with outside systems and potentially have side effects inside of our React code, which normally should be side effect less. It takes two parameters. The first one is the effect function, and the second one is the array of dependencies that determines when that effect function should run again. At bare minimum, if we include an empty array, it will only run the first time this component mounts to the page because it depends on nothing else to rerun. And at the most, if we were to not include this array at all, it would run on every single render of this component. In fact, we can delete this dependencies array and hit save. We'll see that it's going to run both resized and cleaning up every single time this component re-renders. You will pretty much always want to include a dependencies array and think very carefully about which values you want to be watching in order to trigger this effect again. Then lastly, the callback function as the first parameter to useEffect is allowed to return a function which will clean up any of the side effects that you might have created inside of your useEffect code. Returning this cleanup function is something you will want to always be aware of, but it isn't something you always have to do. It's relatively common to have your side effects not have anything that's lingering and needs to be cleaned up. So just know that it's here as a tool for you to use if you need it, but it's not something that you absolutely have to correctly write a useEffect. As always, if you need to go through the content that we've been talking about with useEffect, that's completely okay. It is what I have found to be one of the most confusing topics, not just for beginners in React, but for even seasoned React veterans. useEffect is great as a tool whenever you absolutely need it to kind of have that escape hatch from the React ecosystem and the React functional programming paradigm. But it is something that can be commonly abused for those who don't really understand what it's for or what the common workarounds are for it. With practice, I know that you are going to be an expert when it comes to understanding effects in React. We're actually going to have a chance to apply what we just learned about useEffect and the cleanup function to our Chef Claude app from the last section. But before we find ourselves juggling too many things, I want to tie a nice little bow on our meme generator because currently our get a new meme image button doesn't work. We're saving the array of all memes in state, but what we need to do now is randomly choose one of those meme images when the button gets clicked. This is going to be more of a quick algorithmic challenge rather than dealing with any side effects, but I really want to finish off this app so we can move on from it. So let me type out a challenge for you. All right, your challenge is to get a random image from the array of all memes when the user clicks this Get a New Meme Image button. Once you have gotten a random image from the array, make sure that you write whatever code it is that you need to write so that the image you selected will display on the page. As I've done a few times, I'm being a little bit vague because I want you to think how that's going to work. So go ahead and give this challenge your best shot. Let's work in the same order that the user is going to be interacting with the page. So down on our button, see that's right here. Let's add an on-click event listener for a function we have not yet written. We'll say, maybe call it get meme image. So let's go ahead and write this function. I'm just going to do that in place of the challenge text, get meme image. And this is where it's kind of just an algorithmic challenge. So what I can do is get a random number from 0 to the length of the array. We'll just say array.length. Then we will use that random number to get a random meme object from the array. And then we will need to set state. And that's the state of the current meme, which is the object we're saving in state up here. All right, so let's get a random number. We can just say const random number. And honestly, getting a random number is something I sometimes have to look up, but we can simply say math.floor, math.random times all memes.length. If you've never seen this before in JavaScript, maybe just copy this line and paste it into ChatGPT and have it explain it to you. It's not too terribly difficult to understand, but it's enough to know that this will get a random number between 0 and the highest index in our all memes array, which means we'll never try to index outside of the array. So that was that step. We want to use that random number to get a random meme. And I think I can just do this together. We'll say maybe new meme URL is equal to all memes at the index of random number, and those meme images have a .url property. You weren't expected to know that per se, but along the way of doing this challenge, you probably wanted to console log the new meme that you indexed into, or console log all memes just to see what the structure of each one of those meme objects was. And you, at that point, should have seen that there's a URL property. Okay, and then we're going to set the state. Well, we're setting the state of an object, and we don't want to lose the top text or bottom text. So I'm going to say set meme. I need to know what the previous meme was, and I'm going to return a new object that has all of the properties from the previous meme, but changes the image URL to the new meme URL. This should be straightforward enough for you at this point in the course. If not, that's completely okay, but it is probably a good indication that you need to do a little bit more studying and a little bit more practice before just kind of plowing ahead with the course. Okay, let's test it out. We'll hit save, get a new meme image, and awesome. Okay, we got a new meme image, and this is going to work with all of the images from that memes array. Again, as I mentioned, some of the memes don't just take a top text and bottom text, so it'll be a little bit hit or miss how funny these memes that you create are. Awesome. We can mark the meme generator as completed. I'm sure there's other things that you could decide to do with this project. And as always, feel free to do that. Play with this code, add your own features, and most importantly, go to the Scrimba Discord and share your awesome work. Okay, I want to jump back for just a few short lessons to the Chef Claude project, because now that we understand useEffect, there's a little but really nice feature that we can add to that project. So once you've had a chance to say goodbye to the meme generator, let's continue forward. I wanted to go over a pretty truncated view into refs in React and the useRef hook. I say it's really truncated because we're going to be going through it pretty quickly, only because I have an improvement that I want to add to our Chef Claude app that will require us to use refs. And actually, this reminds me, before we move on, I was getting a little bit bugged that we had not moved some of our components that really should be in a components folder. And really quick, before we jump right into the slides, I did make a couple really simple changes to our Chef Claude app. Primarily, I moved some of the components into a components folder. I think before I maybe had the main component and the header component sitting outside in the project root, but they felt a little more natural inside the components folder, so I moved them there and then fixed the references that we had with our relative paths in each of those components that needed them. Just wanted to make sure I highlighted that before anyone got confused why it was looking a little different. Okay, so what are refs in React and what is useRef? Refs are fairly straightforward. They are very similar to state, except for two major things. The first one is that you can mutate refs directly. With props or with state, we know that it needs to be immutable, and the term immutable might not on its face make a lot of sense, because you might be thinking, well, we do change state all the time. That's how we trigger re-renders in React. But to split hairs, when I'm talking about mutable, I'm saying we're not saying something like, okay, here's my ingredients state, and I'm going to push a new item to my list of ingredients. This would be directly mutating state when we know that we're supposed to use the state setter function. Behind the scenes, React is not just setting our old ingredients array equal to something new or doing something like .push. It's following a more appropriate functional programming paradigm where behind the scenes, it's replacing the old version of state with the new version of state and then kind of queuing it up to re-render the page. So let me get rid of this line. And refs, on the other hand, are things that we can mutate directly. We can just set them equal to something different. And maybe more importantly for us, changing a ref doesn't cause a re-render in React. For reasons that might not be immediately apparent, refs tend to commonly be used for accessing DOM nodes without needing to assign IDs to them and run DOM manipulation commands like document.getElementById or query selector. Refs give us a way to access those DOM nodes. Creating a ref in combination with using a ref prop, which we're going to see in just a minute, give us a chance to do some of those manual DOM manipulation tasks. And again, the reason for this might not be immediately apparent, but that's okay. We're going to get to it. I did mention this is a very high-level overview of refs. I do dive a little bit more deeply into refs in my advanced React course, which is kind of the natural progression after this free Intro to React course, where in one of the sections I cover refs in a little bit more detail and give you a little bit more practice with them. All right, why am I talking about all this? In our Chef Claude app, we are getting our recipe. We can click the Get a Recipe button, and if we look very carefully, we'll see that the scroll bar, when the AI finally gets back to us, the scroll bar on the app will appear and we can scroll down and see the recipe. However, as far as the user experience goes, it's not that great. We don't really give a clear indication to the user that the recipe has finally loaded, and unless their page just happens to be a little bit longer, like we see here, in this case it's a little more obvious. They can click Get a Recipe, and what used to be blank will then become populated with the recipe once it's loaded. But I don't know that we want to bank on this, because their browser might be a little bit shorter like this. So what can we do? Well, there is a DOM node property. I'm putting DOM node here as a placeholder, called scrollIntoView. And as the name suggests, when you select a DOM node and you call scrollIntoView on it, the browser will automatically jump down to that section. So if our DOM node were this entire recipe section, whenever scrollIntoView is called, the browser will jump down so that that sits at the top of our view. And actually for us, that might be a little more jarring. We might want to have this section be what we scroll into view, just so that it's a clear transition between where they see it here at the bottom and they'll still be able to see it here at the top. So the trick is, how do I get access to this DOM node? Well, in vanilla JavaScript, all we would do is we would add an ID to one of our elements, and then we would call a getElementById. And that might be able to work for us just fine. However, React is really centered around having reusable components. We haven't spent too much time talking about reusability. That actually is another topic in my advanced React course that we spend quite a bit of time talking about. We go really in depth on reusability in React. But the point is, if I were to reuse this component or render my main component for whatever reason multiple times, I would end up with two elements that have the same ID on the page. And if you know anything about HTML, that's just a no-no. You're not supposed to do that. So this is where refs come in. Refs give us a chance to access a DOM node so that we can call methods like scrollIntoView. And they are easy enough to create when we use the useRef hook in React. So I'll go ahead and create a new ref here. Since we are allowed to mutate our refs directly, I won't need to do the same thing I did with useState, where I'm given a state setter function. But instead, I can just give my ref a name. Let's call it the recipe section, because I'm going to be scrolling down to the recipe section. And we set that equal to react.useRef. Kind of a standard practice. If I am using my ref to set on a DOM node, I'll initialize it as null. And now that I've done that, what I can do is take any element that I want to have access to the native DOM node of, and I can set a special ref property. Now, I don't actually want to put it on the input, but I'm just using this as an example. Ref is a dedicated property in React. It's set aside for the use of setting these refs on DOM nodes. And so if I did want it on my input, I would say ref equals curly braces recipe section, just like that. Now, let's get it off this input. This isn't actually where we want it. Let's think, where is it that we do want our ref to exist? Remember, the purpose of the ref is so that we can call scrollIntoView on it when the recipe loads, so that the browser will automatically scroll down. And I think we decided that this ready for a recipe sort of call to action would be a good place to scroll down to. So where does this live? I think we ended up putting this inside of our ingredients list. So if we go to our ingredients list, sure enough, here's this section. And we have this div right here that says ready for a recipe. That's this div right here on the page. So this is where I'm going to set my ref. I'm going to say ref equals curly braces, and we don't have access to this recipe section quite yet, because it exists on the parent component that is rendering ingredients list. So I want you to think, how can we get access inside of this child component to the recipe section ref, which currently only exists inside of our main component? What mechanism do we have in React to get access to that? If you said props, then props to you. That's correct. So here is our ingredients list. We can go ahead and say we're creating a new prop called ref. Now, I don't want this to be confusing because I did just say that ref is a dedicated property in React. It means something special, but I probably should have qualified that. It only means that if it's put on a lowercase regular React element. Kind of like how on a button, lowercase b button, I can say on click, and this is the actual event listener. Whereas if I'm working with a custom component like ingredients list, if I say on click, all I'm really doing is creating a new prop, a custom prop, that just so happens to be spelled exactly the same as the native DOM property for on click. The same exact thing goes with ref. So I'm going to set ref equal to recipe section. That's the ref that we created up here above. And this means that I can go to my ingredients list, and we need to make sure, yep, we're receiving props, and I'm going to be receiving this through props.ref, because that was the name of the ref that we gave it. In this case, because we're working with the lowercase d div, regular native DOM element, or what will get turned into a native DOM element, this ref does mean something special. All right, well, this lesson is growing a little bit long, so let's go ahead and do this. I am first going to just console log recipe section so we can get a better idea of what this ref looks like. And we're going to open our console because we need to look very closely at something. I'll hit save. Down in our console, we see that recipe section is an object that has a current property. I'll be completely transparent here. I'm not entirely sure why refs, when they're created, are always objects with a current property, but that's just something you'll have to get used to. The reason it says null is because that's what we initialized it here. If I were to instead say this is a string, and hit save, we can see now it's an object with a current property, and its value is the string that we initialized it with. So that's all that's happening down there. Let's change this back to null. I'll hit save, and now I'll click get a recipe. We'll wait for the API to return its response. And now take a look at this. Our recipe section ref is now an object with a current property, but the value of that current property is a div. Now, Scrimba's console is representing this almost like a JSX element div, but it's really representing a native DOM element for the div where we set our ref inside of our ingredients list right here. Okay, this lesson has gotten quite long. I do have a challenge for you, and it's going to harken back to useEffect. So once you feel comfortable with what we've done here, again, I know it's been kind of a whirlwind, we will jump right into that and actually implement our scrollIntoView feature. One thing I realized I might need to clarify is why, when we first render our page, the recipe section ref is set to null, or the object with the current property is set to null. In my case here, because I am console logging it immediately after it's created on line 11, it's still set to null, and React hasn't yet had a chance to render the elements on the page. As soon as the elements on the page get rendered, ingredients list gets rendered, which then includes this section down here where the ref is being stored. At that point, the ref is then immediately stored as this div, but we're just not getting a chance to see that because we are console logging it before anything has been rendered to the page. Clicking the Get a Recipe button, when the recipe response comes back, it sets state and it re-renders the component, which then reruns our console log line, and we get to see, even though it's a little bit delayed, the fact that the ref has been accurately set on that div. In fact, I think we could also see that if we just add another ingredient here. I'll hit enter, and yeah, sure enough, in the console we can see that the recipe ref is set to the div. Just wanted to clear that up, just in case anyone was confused why it was initializing as null. Okay, let's apply refs so that we can add the feature that we want to add, where the page will scroll down. So the problem that we have is that we want to scroll down to this ready for a recipe section only after the Claude recipe section is rendered to the page. Or in other words, when recipe, as we're initializing it, is not an empty string anymore. Maybe keeping in mind that this is a section all about useEffect, I'm going to put a pause in here and give you a chance to think from a high-level architecting overview what might need to happen in order to solve this problem or add this feature. If we think about it, we are hoping to create a bit of a side effect because we want to scroll the browser down, which involves doing a manual DOM node method call, and we want to synchronize that action or that side effect with a value that React is holding in state with recipe. And so this brings us to your challenge. I want you to add a new side effect that calls recipeSection.current.scrollIntoView. But it should only do this if the recipe is not an empty string and if recipe section.current is not null. That's an important thing we'd want to make sure. We can't scroll it into view if recipe section.current is not the div DOM node, but is null. We're going to get an error if we call scroll into view. So we would need to make sure of that as well. The important part of this challenge is I want you to think carefully about what values you would want to include in your dependencies array. What will this side effect actually depend on in order to perform its action correctly? Once again, I'm being a little bit vague. I want you to put on your thinking cap and give this challenge your best shot. So go ahead and start working on this challenge. All right, well, to create a new effect, we're going to call react.useEffect. Alternatively, of course, we could just destructure that from the React library up above. UseEffect takes two parameters. We have a function and a dependencies array. Let's worry about the dependencies array next. We'll first work on this function. So the clue to the code we're going to have here is written in the challenge text, if the recipe is not an empty string. So we'll need to add a conditional here. If the recipe does not equal an empty string, we could theoretically also just say if recipe is a truthy value. I think I'll opt to be a little more explicit and specifically say if it's not an empty string and recipe section.current does not equal null. Once again, I probably could just say and recipe section.current, but we'll stick with being explicit here. If those things are true, then I know that I want to call recipe section.current.scrollIntoView. Well, let's think carefully about what we might want to include in the dependencies array. What would happen if we put nothing in the dependencies array and we just left it as an empty array like this? In fact, I'm actually going to put in a pause here so you take a second to think about that. If our side effect depends on nothing, which is what it means to have an empty array here, then this useEffect would run when the first time when the component first mounts, and when the component first mounts, recipe is equal to an empty string, and so our scroll into view would not get called. This is exactly what we would hope that it would do. We don't want it to try and scroll down to it right at the beginning when the component is first mounted. But because we're telling it that it depends on no external values, then it's never going to call this useEffect function again. So an empty array is incorrect inside of our dependencies array. We want React to rerun this side effect anytime that recipe changes. If the state value for recipe changes, we want it to rerun this effect to determine if it's time to call scroll into view. So let's clean up this challenge text and we'll hit save and give this a shot. I'm going to click get a recipe and check it out. It scrolled us into view. That's awesome. Now, one thing I'm sure that you noticed is that it did it pretty abruptly. It just kind of jumped down the page immediately. And if you are already familiar with the scroll into view method, you might be shouting at your screen, wait, there's a better way to do this. Unfortunately, there's a small limitation, and this lesson has gotten a little bit long already. So we're going to talk about that bug in the next lesson and see a little bit of a workaround for it. But in the meantime, if this useEffect that you wrote here made sense to you, then kudos. That represents a big leap in your understanding of side effects in React. And if it didn't, that's okay. Having a solid understanding of useEffect took me quite a while to grasp. So it's definitely nothing to be ashamed of, but it does give you an indication that it might be time to go back in the course and maybe review some of the lessons that we've had previously. Once you're ready, we are going to add some code that will do a little bit more of a smooth transition down to this ready for a recipe section, just to make the user experience a little bit better. In the previous lesson, we got our scroll into view to work, although we did notice that it's a little bit abrupt. The user experience isn't as great as it could be if instead of immediately jumping down the page, if it were to smoothly scroll down the page to this ready for a recipe section. And the reason that it's jumping immediately is because that's just the default behavior for the scroll into view method. But as I mentioned, if you've used scroll into view before, you might be saying, hey, there is a way to do this, and that's by adding a configuration object where you can say the behavior should be smooth. And if you happen to be following along on your local machine, then you could put this into your code and it would just work correctly. However, for those of you that are following along here in the Scrimba interface, there is a small problem, and that is that, well, behavior smooth just doesn't work. Let me show you what I mean. We'll click get a recipe, and when the response came back, we can see it might have scrolled like a pixel or two down the page, but it simply didn't scroll smoothly down to the section that we wanted it to. And the reason for it is a little bit interesting. It's actually not a bug in Scrimba. It's a known bug in at least Chrome-based browsers that use an iFrame. For whatever reason, if you have an iFrame that you're trying to run scrollIntoView with a behavior of smooth on, it just doesn't work. And our Scrimba environment is a little bit unique because we do have an iframe that displays our mini browser. So this behavior smooth isn't going to work inside of Scrimba, but in your local environment and pretty much everywhere else, unless you're using an iframe, it should work just fine for you. I did find a little bit of a workaround. I'm not going to really dive deep into the code, although I'm going to paste it here for you to have a chance to play with, and just so we can see that it's working. So right here, it's simply figuring out exactly where on the page or in the viewable area of the browser that it should scroll down to, and then it's using window.scroll with behavior smooth. And for whatever reason, this works just fine inside of a mini browser. So let me hit save. We'll go ahead and click get a recipe. And sure enough, we got a nice smooth scroll down to where we wanted it to go. I'm going to leave this line of code commented out just so if you refer to this, you can know that this in pretty much every other environment is going to work just fine for you. But I'll leave my real code here so that we get the behavior that we want. Great work making it this far through this section. I know that side effects can be a little bit hard to grasp, and I know that from going on about 8 years of teaching React at this point. Hopefully, the way that I presented it was able to demystify what side effects are and how and when to use useEffect in React. If it does feel a little bit hazy or cloudy to you still, that's completely okay. Use this as an opportunity to join the Scrimba Discord if you haven't already and start asking questions there. See if any of our amazing community members can help clarify for you when and how you should be using useEffect in React. And believe it or not, this essentially wraps up the scope of all the topics that I wanted to talk about in this Intro to React course. However, because we're here on Scrimba and because we have such a strong emphasis on getting your hands on the code, for the remaining of this course, we are going to be in full-on project mode. We have some awesome things coming up. So even though we're done with these topics, the real benefit of this course is going to be with getting your hands on the code and practicing as much as you can building projects. Let's do a quick recap of what we've learned in this section, and then we are going to dive headfirst into some awesome project building experiences. Wow, can you even believe how far we have come in this course? It truly is mind-blowing, especially if you look back at some of the topics we were covering in the first section of the course. Your understanding and capabilities in React have truly expanded. We have come to the end of the new instruction in this course. That said, some of the most important tasks I have yet to give you in the upcoming sections. Before we jump straight into those, let's do a quick recap of what we have learned in this last section. We started off with some quick lessons about controlled components. Since we wanted to update our state on every single keystroke of our input boxes, we had to make them into controlled components. React 19 has introduced new ways to handle forms, which are quite a bit more intuitive and in line with the native web platform, but there are certain circumstances where controlled components can still be important to know. We took a quick dip into theory as we talked about functional programming in React and how React adopted the paradigm that it currently has, which helped us understand the whole concept of side effects in the first place. Then we looked into how we can fetch data with React, not necessarily when a user interacts with our page to request that data, but when the app loads for the first time. And that led us into understanding the actual application or syntax of applying side effects in our React app. You're about to dive into some really exciting projects, and so this would be a great time to express your excitement about finishing Section 4 over in the Scrimba Discord community's Today I Did channel. Clicking the screenshot will take you directly there, where you can celebrate with the other people who are also completing great tasks today. All right, I can hardly wait. Let's jump into some project work.